go into the learning objective and see how we can basically work through the case studies. And the first one is, you already know the learning outcome, right? The objective. As you see in the appropriate diagram, describe the anatomy of autonomic nervous system, histology of the endocrine. And then we want to compare and contrast between, yes.
You just cut off just now.
Just cut off, okay. That is basically the 4 learning objectives that we are going to go through and see how we can actually meet the learning objective through these case studies. Okay, so I'll just move on to the next one. The first, your, what you call this, your case, your set A. So this is the case of 2 CUCMS students by the name of J and K. Both of them are 19 years old. One is every one of us is actually under stress, so the same thing as this. But one is interested, as very J, interested to become a very excellent doctor, whereas the other one is going to be an engineer. So we find it very stressful to basically take the medical courses. So you already know the case. So we look at the first set A, question 1. What is anything that can actually prevent us from the normal way of doing things is very stressful. As I say, even during the MCO or not our MCO, we are also very stressful. Right. So we sometimes say that everyone around keep us stressed, or you sometimes that is putting pressure on us that we can or cannot cope with the pressure that is placed upon us. So people are stressed from very stressful. We can't go out to meet our friends, or sometimes we actually join in the social media and there's basically information overload. And also now, because of the changing situation, there's an increased pace of life. So all these are actually very stressful. So to cope with these changes, we have to basically face stress, and which means that anyone can be affected. Okay, so life basically is full of stress, so everyone is affected. And this is basically, especially the modern life, the stress situation to us is mostly chronic and often psychological. And this slide I already showed you when we are doing the module 6. Okay. So we already discussed what is stress, what is the significance of stress. So sometimes we say is stress actually benefits? Yeah. So stress is a body reaction to any stimuli that disturb the equilibrium or homeostasis, which means that anything that can disturb the equilibrium or the homeostasis is basically stress to us. So when the equilibrium of various hormones is altered, the effect of these changes can be detrimental to the immune system. Okay, the same thing, because basically once you are stressed, the immune system is the first one that is basically to be affected. So stress is an adverse reaction a person has to excessive pressure or other type of demand placed upon him or her. And here we see the distinction between the pressure and the positive states. If managed correctly, and stress will be detrimental to our health if it's not well managed. So the ability to cope with stress is largely dependent on individual own threshold, which means that basically some of us are able to take stress, pressure more, whereas the others, we can't. So it actually varies from individual to. So Hans says that the only person without stress is the person who. Okay, the only person without stress is a dead person, which means that every one of us who is living is always under constant stress. And he maintains that stress should be viewed as stimulation to growth and development, challenge and variation in life rather than just a static one. So at the same time, two persons can be subject to the same stress stimuli, but one does not notice at all, whereas the other one can be very stressful. If you look at K, J probably enjoy the stress that he has, whereas for the K, he doesn't really enjoy the stress that he has when he was studying in UCMS. Okay. So basically, there are many different types of stress. With these are the slides that I already shown you, so I'm just going to skip through. Are usually negative and harmful stress. So you have hyper-stress and hypo-stress. Some people can be hypo-stress. So the other slide I'm going to show you is the effect of stress, which is called general adaptive syndrome. This is basically looking at the performance of arousal. So initially, if the stress level is low, basically our performance will increase until we reach eustress. Then you have an optimum performance. But anything beyond the second stage of stress, there's the eustress, basically is high stress. That means it's usually result in burnout for us to actually try to overtake the stress problem. Yeah. So what is the stress system? We already discussed the stress system. The concept of stress system, you talk about receptor, efferent pathway, control center, efferent pathway, and effectors. So the stress system we have already discussed in module 6. So basically, I'm just going to skip through and we talk about receptors, and we told you receptors. That's what we hear, we see, we touch, we taste, we smell, the pain, temperature. All these are the interoceptors that actually sense the stimulus. So there's no special stress receptors that actually sense it. So it's all our normal receptors that actually sense the changes. And the internal receptors are interoceptors that basically monitor our body, blood pressure, glucose level, osmolarity, pH, partial pressure, oxygen, and carbon dioxide. So these are the receptors. We already mentioned that, so I just going to go through faster. So the control center I already mentioned, so it's already been discussed. And then the effectors. Okay, the effectors is either basically is your skeletal muscle response. That is the main effector that you respond to. And the subconsciously basically is why your hypothalamic adrenal axis going through the adrenal glands, adrenal medulla. And also stressor from the internal environment is usually going through your nervous system. Okay, so I just going to skip through this, and then the next one, we'll compare and contrast between psychological stress system triggered by internal stimuli and behavioral stress system triggered by external stimuli during specific components. So the stress system is basically, even internal, we know that the internal stimuli, as I say, the receptors are basically those that monitor our blood pressure, our partial pressure, oxygen, and carbon dioxide. All these are basically internal stimuli that actually be monitored. Okay, any changes to that is going to have an effect, and it's going to be a response by our body system. Okay, so for physiological response, basically we look at sympathetic overdrive. Behavioral response, we look at altered emotion, fight and flight reaction, and behavior adaptation. So for physical response, basically sympathetic will be activated, and then you have the heart rate, stroke volume, cardiac output, blood pressure, and also changes in the GIT tone, okay, and motility. And also it activates the hypothalamic pituitary adrenal axis. This is basically to increase the plasma cortisol, so the increase in cortisol secretion. And then the third question is, how are the nervous system and endocrine system involved in stress? So we know that both of them will be activated because they are all from the hypothalamus. So the nervous system are basically activating the adrenal medulla to release the epinephrine, and then you have the release of CRH ACTH, and then going to your adrenal cortex to release glucocorticoid and also some mineralocorticoid, but mostly we look at glucocorticoids. Okay, so you can compare and contrast with. So for nervous response, they are basically short-term and they are fast. The response is, as I said earlier, that it can be minutes or seconds compared to the more of the hormone endocrine response. They are more prolonged and they are lasting longer. Okay, so the next one, question 5. Any questions so far? I believe you don't, because these are, yes.
Does stress actually really affect aldosterone in this case, actually?
Aldosterone. No, you basically is more of releasing of CRH, ACTH, then you have more cortisol rather than aldosterone, so it's very much less. So it's more.
There is still stimulation of, there's still release of mineralocorticoids, right?
Yes, there is some mineralocorticoid. Mineralocorticoid, as we mentioned to you, that is actually activated through your angiotensin and potassium level. Is that okay?
Yeah, but doctor, I just want to know that, let's say, because you have higher than normal CRH levels and you have higher than normal ACTH levels, so then again, this will also influence a higher level of mineralocorticoids, right? So
yes. So for prolonged stress, then this probably might activate your mineralocorticoid rather than short-term stress.
Okay, all right. Thank you, doctor.
Okay. So people who are under chronic stress, yes, people who are under chronic stress, then you might activate your mineralocorticoids. Okay, because the ACTH has some action on mineralocorticoids, but they have to be very high level. Any questions so far? If not, I'll move to question 5, discuss the effect of stress on immune system. And we know that basically stress it actually boosts the immune system. So most research has shown that a negative effect of stress have on the immune system, mostly through the study. Participants were subjected to a variety of viruses, which means that they actually use the virus to test on the patient. Usually they use respiratory viruses such as influenza virus vaccine, and then they compare those which are under non-stress control group and those that are under very stressful control stress patient. And then from the study, they found that patient will basically respond badly when they are infected with the virus, given the stress index that is high. And the result also shows that the increase in score in the stress index correlated greatly with the severity of core symptoms, which we actually experience. So basically that when we have been stressed, usually there's important exam and you have to prepare, and usually you find yourself easily getting cold, runny nose or having fever, because you are usually easily infected by viruses and respiratory viruses. Okay. And there are also studies shows that men with HIV were 2 to 3 times more likely to develop AIDS when they are under a normal above average stress. That means if they are under severe stress, they generally will have a much worse effect. This slide already showed you previously when you study on that on module 6. So the same thing, it basically shows that short-term stress is actually a boost to the immune system, whereas long-term or chronic stress actually can actually wear down the immune system of the person. So how does the stress actually affect? Is basically increasing glucocorticoid and also cytokine, and we know it will to actually suppress the immune system. Okay, so stress affect the immune system in many ways. the immune system protect the body from viruses, bacteria, anything that are different from the body that does not recognize. Whereas immune system see intruders and send message to attack it. But the white blood cells, which is basically have many different types. There is type the B cell, T cell, and also natural killer cell. We know that the B cell secrete antibodies, whereas the T cell actually directly kill the intruders or the viruses or bacteria. Natural killer cell actually kills the cells that have been infected by the viruses or bacteria or viruses. So these white blood cells produce cytokines which actually fight off the infection. But when by doing so, the immune system able to communicate with our body system, our brain, to tell that the body is actually ill if they are infected by virus. A very stressful experience, the immune system will start to produce natural killer cell and cytokine, which actually tells the body that the person is sick. So under chronic stress, you basically produce the same kind of information to inform the brain that the person is actually sick. And these symptoms basically include fever, sleepiness, lack of energy or no appetite, or basically having a running nose or flu-like symptoms. Okay, so this is how it's able to basically cause the problems of suppressing the immune system. Okay, so this is useful because the body actually go through a stress injury and they are basically under recovery to try to recover from the effect of the viruses. Okay, so any questions about the effect of stress on the immune system?
Wait, sorry, doctor. That means in people who are have chronic stress, they have lesser cytokines, right?
They have more of this is called, sometimes they call this pro-inflammatory cytokine and also inflammatory cytokine. Okay, they are also anti-inflammatory cytokine. So they actually have more anti-inflammatory cytokine compared to pro-inflammatory cytokine. Okay, which means that it's not that they have less cytokine, they have more anti-inflammatory cytokine that is being released. So which is basically inhibitory for inflammation.
And this is a direct effect from the cortisol.
Yes.
Okay.
Most of the effect is due to cortisol. Yeah. Okay. Yes, for chronic, it will actually start to reduce in repair of the organ system that have been under wear and tear, because your body is trying to conserve more glucose for use during emergencies, especially your fight and flight reaction, rather than for repair and growth. So this. Okay. Okay, so I'll move on to number 6, list down the psychological and pathological condition associated to stress. So in my slides, I have shown you a slide. Okay, psychological aspect of stress, that's basically, we are very clear about it. When the person under stress, the first thing is they usually affect the behavior. Okay, so when they actually look at a study of children that have been maltreated or abused, usually these children will show signs of dysregulation of affect, provocative behavior, and avoidance of intimacy, and even disturbance in attachment. That means they are not close to anybody. They try to avoid people. Okay, so these are psychological aspects for especially those abused children or bullied children. And most of these stressful events will then proceed to become anxiety. The person will be stress. This is the events that will go from initially avoiding people, close and become provocative behavior, and then finally proceed to become anxiety, and later become depressed. Okay. But for the pathological condition associated with stress, usually is heart diseases, and researcher has actually able to show that basically in long-term stress, the type A personalities have higher risk of high blood pressure and heart diseases or chronic heart failure. So generally the type A personalities, because these people with type A, they tend to be angrier type, so they tend to be under very stressed out easier. And for asthma, it becomes worsen. If they have asthma, if they are under stress, the asthma become worsen. And obesity, because of excess cortisol level, of the fat away from the other organs, so they are mostly deposited in the belly. So you have central obesity. For diabetes, it actually becomes worsen because of rising glucose level due to cortisol. And also for GIT condition, there are GERD, irritable bowel disease. So it becomes worse because of the probably reduced motility due to the effect of sympathetic activation. Okay. Any questions for question 6? If not, I'll move on to question 7. So discuss the concept avoidance stressor and dealing with stressor. Give experience faced by Jay. Any questions before I move on? No? Okay. So these are just a summary of the stress system. I just move on. Number 16, avoiding. So we know that Jay basically exam, he likes exam. Compete in sport, friends break in the fine tradition, he become angry, and he don't actually like friends that actually come late to classes and not willing to do group work cooperatively, even cheating in doing assignments. So all this actually stress Jay more compared to actually taking exam and participating in class discussion. Compared to K, he doesn't even enjoy curriculum or co-curricular activity in CSNS. He actually hates CST and reluctant to attend reflection session. So all this basically making problems, even relationship with your girlfriend are strained, spending more time playing games, computer game, because this is the...
While K dealing with stress by playing computer games, smoking.
He is more of avoiding. K is probably avoiding the stress by playing computer game rather than J. J is dealing with the stress.
Alright.
Yeah. So you have to get that right, because J is actually dealing with the stress, because as I said initially that every one of us is facing stress every day. So it's how we deal with the stress. Okay. Whereas compared to K, he's trying to avoid stress, so by probably playing computer game or smoking or doing something stupid. Okay. So I'll just move on to question the set B, yeah?
Alright.
So, doctor,
Yes.
Dealing with stress means to overcome the stress.
Yes, during the stress, that means you actually deal with it, you overcome the stressor. It means you take it, you face it rather than run away or do other things rather than try to avoid it. Let's say you know that you are having an exam that is coming and you give all the excuses. You find that you say, why the exam is given such a short notice? Why not do it some other days? Why not? You give all the justification. This is avoiding taking the exam. For example, I'm just saying for example. And then for the other person, you know that the exam is coming, just prepare it and accept it as part of your learning. So you will basically, rather than try to avoid taking the exam. Okay?
All right. Thank you, Doctor.
Okay, thank you. So I move to set B, yeah?
Doctor, so we're talking about both good stress and bad stress, right? So in the case of J, we can talk about, for example, participating in class discussion and all.
Yes, there is a good stress. Okay. Hello, Jana?
Yeah, it's okay, Doctor. Sorry, my Wi-Fi isn't working properly.
Okay, everyone having the face the same problem. Okay, so I'll just move on to set B. Set B, I think I'll still look at set B. Okay, question is draw and find the diagram or lateral section of the focusing on the limbic system. So we are looking at is basically trying to focus on the limbic system, which is actually very close to the hypothalamus. Okay, and then pituitary glands. These are all being already shown to you previously, so you know where is the location of the pituitary glands, auditory center. Showing the location. Okay. So question 8, draw the arrow and the list of stressor part of the nervous system, external stressor, all this. So here, slide is basically, you can't see my, I will just change it to pointer. I should have used the, sorry. Okay, so I can try to change it to become a pointer. Yeah. Okay. Okay. So here, this slide is basically showing you about the interaction between the higher brain and the hypothalamus and the limbic system. Okay, and also all the internal stimuli that is going through and to the hypothalamus, and also going in and out of the hypothalamus. Okay. So we already. Oh, okay, the limbic system function. Okay, the motor center, and the behavioral response. Okay, we look at the next questions. Indicate the path of the hypothalamus where the sympathetic nervous system and the parasympathetic started. Okay, we look at the hypothalamus. This is basically the hypothalamus. So all these are basically denote the brain area that is part of the central autonomic network, the blue one. So these are basically part of the central autonomic nervous system that actually finally activates the sympathetic nervous system and also the parasympathetic nervous system. Okay, so all these have an influence on the sympathetic and parasympathetic nervous system. Whereas the hippocampus is modulating all these the blue colors, the blue central nervous system. Okay, the thin blue line, these are basically the parasympathetic nervous system, and the red one are showing you the sympathetic nervous system.
Sorry, doctor, for examination purpose, are we supposed to know all these areas and the connections?
No.
Okay.
You generally basically knows that the influence of hypothalamus is also over the sympathetic and parasympathetic nervous system. Basically, it has an influence over autonomy. Okay. Because sometimes we don't actually know where is the autonomic nervous system starts. Okay. It actually started from prefrontal cortex, and all these basically influence the sympathetic and parasympathetic nervous system. Okay. So the main integration center of the autonomic nervous system is the hypothalamus. So the hypothalamus is the main integration center. Okay. Okay. So it's you don't the limbic body is the main limbic system which is related to emotion. So this emotion have also an influence on hypothalamus, which actually influence the autonomic nervous system. Okay. So draw the neuron. Okay. Okay. When are these neurons stimulated in J and K? So when they are stressed, all these neurons are basically stimulated because the hypothalamus is the one that is going to receive all the information and integrate it, and it's going to be activated, the autonomic nervous system. Then draw the association trigger neuron. Okay, then you have the sympathetic ganglia. Okay, this is also another slide to show you how communication at subconscious level between the limbic system, okay, emotional input, and the cerebral cortex, and also the system. Okay, and this basically, or then regulate our body response, especially our sympathetic nervous system. So amygdala, these are the emotional center. They actually influence the hypothalamus, okay? And this then basically influenced by the limbic system. And this whole thing basically also influenced the autonomic nervous system. Okay, then we talk about the preganglionic. Next one. Okay, so these are the sympathetic center. So there are about 22 ganglions for the sympathetic. Okay, there is not just it starts from the thoracic to the lumbar region. So these are the sympathetic ganglions that run parallel to it. Okay, some of the preganglionic fiber basically innervate the postganglionic neuron in the ganglia. Okay, some actually run directly and go straight directly to the adrenal medulla. So these are the ones that actually go directly to the. Okay, the rest of it can actually, that means that there is only not just one, some of them can actually synapse with many of the ganglions. Okay, so on average, it synapse 1 to 20, but you don't have to know actually the numbers because this is just a guideline. So not necessarily T8, let's say T4 synapse with only the ganglion at T4 level, no. We actually synapse sometimes high up is actually going down. Okay, so these are just the pictures to show you. So the one that is going to the sympathetic fiber to the organ system coping with stress like cardiovascular, respiratory, and the gastrointestinal and also urinary. So you can basically see that all these postganglionic neurons activates the lung, the heart, the GI, and also the kidney. Yeah. Okay. So question 11, then you have questions 12. Okay, 11. Basically autonomic nervous system showing you the autonomic nervous system that actually activating the effector, the smooth muscle, cardiac muscle, and endocrine glands, and also the adipose tissue. Whereas the adrenal sympathetic pathway go directly to the adrenal medulla and release epinephrine. Okay. As for your somatic motor, it go direct, and this is usually known as corticospinal tract. Going directly, this is your upper motor neuron, which finally synapse with your lower motor neuron and then innervate your muscles. Okay, and it release acetylcholine from skeletal muscle contraction. Okay, so just move on to set C. So we cover set B. Any question on set B? No. Okay, so we got only 20 minutes to cover another 3 more sets. Now we look at question 12. We talk about compare and contrast between acute and chronic stress. I think in this case, you have already know the acute stress. And see the next one. Okay. So you can actually compare the chronic stress and acute stress. You can compare that. Okay. For acute stress, generally, most of the time is activating the nervous system, basically through the sympathetic nervous system. So it's much more faster and usually short time compared to the chronic stress, and usually it's more prolonged, and you have CRH being released and ACTH, then only the glucocorticoid will be released or cortisol will be released. So you can compare between these two. Yeah. Then explain the acute effect of stressor on J and K phase on. You already know, so list the receptor for each stimuli. So what is the acute effect of stressor on J and K? Anyone?
Increase heart rate.
Yeah, increased heart rate. So if you look at the increased heart rate, okay, which means that for sympathetic is direct going through your sympathetic fiber that basically activates the heart, so to increase the heart rate. Okay, so these are basically the adrenergic receptors that's being activated. Okay, so the SA node increases the heart rate, which basically increase the cardiac and also the muscle contraction. Okay, the same thing, it actually works for K. Yeah, if you look at acute stress, is both of them are actually being worked on, are actually the same, so there is not much different. And then compare and contrast the useful stress and wasted stress. Increase in glucose level. Okay, so to activate and increase your glucocorticoid to release cortisol, so your glucose level will increase. So if this excess energy is not being used, then it becomes a waste stress. Compared to here activation, which basically activates the increase in heart rate, blood pressure. This is basically short term. Yeah. Okay.
Doctor.
So yeah.
For long-term stress, can we say the wasted stressor is proteolysis?
Proteolysis. Yes. Proteolysis is actually one. The other thing is there's an increase in glucose level because the proteolysis is mainly due to the glucose that is not able to get into the muscles, the skeletal muscles, and also some other cells that require glucose. So basically, they break down proteins for internal glucose. For long-term stress, it's basically protein and fat converted to become glucose. Okay, and there's an increase in blood sugar level, and the other one is suppressed immune system. So the effect is mainly due to an increase in blood sugar level, which the body cannot use, and this will be then distributed away from the center, so they start to accumulate in the belly. So you have a central obesity or increased body weight. Okay. So now compare and contrast with the stress. Okay, there are hints given, and then finally the example: blood vessels to organs are considered, but some to the skeletal muscle, the brain, the heart are dilated. Why? Because they have different receptors. Okay, those that go into the skeletal to the blood vessels, they have alpha 1. So the one that go into the skeletal muscle, the skeletal muscle, the brain, and the heart, they are basically going to relax because of different adrenergic receptors. Okay.
Doctor, do you mind repeating that again?
I'll repeat again. Okay. The innervation, why is that some blood vessels to most organs are considered, but those skeletal muscle, brain, and the heart are dilated because there are different adrenergic receptors. They have alpha 1 receptors on the smooth muscle. While those blood vessels going to the skeletal muscle, the brain, the heart, they have beta 2, which will relax. Okay. Okay, Azan will just stop for a few.
Oh, right.
Yes. No, you can ask, no problem. Amal, you can ask.
All right. For the you said that the wasteful is when there's energy produced but not being used, right? Yes. So does it mean for the short-term stress response can also be wasteful if the energy produced is not used?
Yes.
Oh, all right.
Example. You get angry, your friend, you were very angry. Basically, you were building out all your energies, but you can't actually punch him or you try to hit him. Basically, it's boiling inside your body. So these are considered waste. So sometimes to me is things simple things that can be solved. Just take it easy. Don't try to build out the energy, wasteful energy inside your body, which is usually bad. Because when you are simultaneously activated, your blood vessel constrict, your blood pressure actually increases. And also there's increase in glucose. Azan to finish. Okay, so the other thing is, I give you another example. Let's say if you get very angry with your friends, but you can't do anything. Let's say your friend did something bad, that he is not participating in a group work, and you get angry with him. So what you normally do, because you are going to build out all the stress energy in your body. So at the evening time, basically, once you go back, go and play some games. Don't keep on thinking about the problems that you are having with your friends. Just ignore it and forget about it. Okay? Probably you can tell him nicely. Yeah. Yes, Amma. Even the constriction of your blood vessels increase in heart rate, that is actually a waste if not being used directed at the right way. It's basically a wasted stress. You get angry, basically your blood pressure increases. So they say that your blood is boiling. So blood pressure increases. That is actually waste if you can't do anything about it. So if you have problems that you know you can't do anything about it, don't think about it over and over again, because it's going to become a chronic stress to you. Okay, so take it easy and then just take it and let it go.
Doctor, does crying help you release the stress you're feeling?
Yes. So for ladies, generally you will cry, but for men, I don't think they are going to cry. What they do is you can actually punch the punching bag. You can do that, or you can just go out for a run, or walk around, look at other things, so you can actually use out some of the excess energy that you build up to be released. That actually help to relax and rather than build out the waste stress. Is that okay? Yeah, if you like to scream, you can scream. Things that you can emotionally do, things that emotionally that you do that you can feel relaxed about it, then yes. But some people like to play games, some people like to sing or play guitars, musical instruments, all these things that can actually use out the excess energy that you build in your body is good to release the stress. Is that okay? No, fully neuron pathway.
I was thinking, because remember when the topic when we're doing stress, we were talking about how like for stress, your body is not able to be distinctive. Like it doesn't know if it's a physical threat or like it's a psychological threat. So most of the
Yes.
time we prepare for fight or flight reaction. So can you
Yes.
consider that a waste if you don't actually end up running or like doing whatever?
No, because the only thing that we know, your body doesn't actually knows the difference between the stress that is being built up, either useful or wasteful stress. As long as the energy that is built up that is not being used is considered wasteful. Okay, so it's you consciously have to know that basically some of these things that is bad, then you should be able to do something to release the stress. Okay.
Yes, doctor.
Okay. So basically, I already answered all the which of the one is wasteful. So we already answered that. So we move on. And chronic. So draw diagrams. I think this one already done. Yeah. So we go to question 15. Question 15. We talk about. Okay, this question 15. Yeah. Question 15, we look at the magnocellular. So this is the magnocellular fiber that is going to basically release in the posterior pituitary glands, posterior pituitary gland to release the hormones. Whereas the parvocellular nuclei, they are the one that is going to secrete in your medial amygdala to release the primary capillaries network to go to your adrenal anterior pituitary to effect on the troops. Okay. So this one is basically released CRH. CRH being released by the hypothalamus, and it's going to affect pituitary gland to release ACTH, which then affect the adrenal gland to produce cortisol. Okay, so which hypothalamus first activated first when stressed? Which CRH, basically CRH is released because of stress. And also all the other hormones, then you have other hormones that is being released, basically ACTH, then you have cortisol that is going to be released later on. Okay. Then you have epinephrine that is released from the adrenal medulla through the activation on the nerve. So I move on to set D. Yeah? Okay. Question 16. We talk about find and draw the adrenal cortex. So look at the adrenal cortex. Okay, this is the adrenal cortex, basically the zone. And then this one already shown you in the module 3. Okay, fine. And then what happens? Yes. What happens when the enzyme are activated and how this happened to J and K? So to them, basically, your adrenal cortex these are the one that produce the cortisol. Okay, and then your medulla is the one that release the epinephrine. Okay, what happens when enzyme activated? Basically, if the enzyme activated, then you have the hormones that is being produced. So it depends on which zone that is being activated. Okay. So granulosa, basically, we know they are going to produce aldosterone, whereas the fasciculata and reticularis is going to basically produce your cortisol. But they also produce your DHEA, the androgens. So it depends on the hormones. So the type of hormones that they have, that is the one that actually helps to produce cortisol or aldosterone. So it depends on the enzyme. Okay, so indicate its receptors and explain how ACTH activate the cell to synthesize and secrete appropriate hormones. Question 17. Yeah, ACTH stimulate CRH. Okay, CRH will act on your corticotropes, which is your G-alpha S. Okay, to release ACTH. ACTH is going to act on the granulosa cell to release basically cortisol, which is also G-alpha S. Okay. So what happens when question 18, how is it regulate the first page and how CRH is related to the stressor? So any changes, any stress on the hypothalamus, the stressor, this hypoglycemia, hypotension, fever, trauma, surgery, anything that actually have a stress on the hypothalamus will activate CRH release. Okay, so the release of ACH from the anterior pituitary is regulated by hypothalamic CRH and cortisol, ACTH or CRH. So cortisol level will also basically regulate itself by feedback, negative feedback regulation. Okay, question 19. Use appropriate diagram to describe mechanism of action of cortisol. So we know cortisol, what is the main effect. So the cortisol, oh yeah, I have a call. Okay, there seems to be no cell that lack glucocorticoid receptors. Where is glucocorticoid receptors found?
Intracellularly.
Okay, it's intracytoplasm. I just take this call for a while. Is that okay? Just.
Alright.
Take a call. So we know that basically all cells have glucocorticoid, and the glucocorticoid basically they are intracellular or intranuclear receptors. So this is the one that is going to affect the gene synthesis, which okay, even extrahepatic tissue is going to mobilize amino acid. Okay, it inhibits glucose uptake by the muscle and the adipocyte, and also stimulate fat breakdown in the adipocyte. So basically, glucocorticoid, it helps all this, and it actually stimulate erythropoiesis, erythropoietin synthesis in the kidney, and basically will also increase RBC production. Yeah, and we know that basically the increase in cortisol also inhibit immune suppressive. Okay, so relate this to the medical problem faced. That is the problem that K is having. So what does K having? You have a headache, right? So if we refer back, what does K actually having? He is having strain, muscle tension, mouth ulcer, frequent cold. Secreted. Okay. And then use appropriate diagram to describe mechanism of action. Okay, you can use that. And then number 20, number 16 done. Yeah? We know the effect of cortisol, mechanism of action of cortisol. Number 20, okay, compare and contrast with Addison. Cushing disease and Cushing syndrome. So ACTH excess is known as Cushing syndrome. So the disease is, okay, the form of Cushing syndrome caused by functional adenoma is known as Cushing disease. So all the excess cortisol hormones with unknown origin, they are known as Cushing syndrome. If you know that the origin is functional pituitary adenoma, then you call that Cushing disease. Okay. Whereas Addison disease is basically adrenal insufficiency with both mineralocorticoid and glucocorticoid being usually deficient. Okay. So number 21, indicate the importance of mineralocorticoid regulation of aldosterone. And we know that mineralocorticoid, the main regulation is angiotensin 2 and concentration of potassium in the blood. These are the main regulations. Unless you have very high ACTH level, then you have some effect of able to increase mineralocorticoid production. Okay. Then mechanism of action of mineralocorticoid mainly to increase sodium absorption. This also help to increase water. So mainly it have an osmotic effect directly related to increased absorption of sodium. Yeah. But the increased renal excretion of potassium, so it can actually lead to increased sodium secretion and also increased renal excretion of hydrogen ions. Okay. You already know the action of a mineralocorticoid. J and K be consciously exert control. So where J and K can actually consciously exert the control, as we discussed just now, you have consciously, the only place you can actually consciously control is your cerebral cortex, which means you know and how to basically control it, the stress level, okay, or you are basically dealing with the stress, okay. So people can exert conscious control over some autonomic function by developing control over their thought and emotion, which means that you can control your autonomic nervous system by feeling. Sometimes, for example, feeling of extreme calm achieved during meditation. So people who meditate, you can basically influence the parasympathetic center to basically reduce your blood pressure. Okay, but sometimes actually, if you are having a severe headache, you take a bath, okay, which basically cool your body down, and also if you are Muslim, read some Quran. Okay. So we are done with step D. Any questions so far?
Doctor.
Yes.
So for the system that we can control, can we say the somatic nervous system?
Somatic nervous system. Somatic nervous system basically control your skeletal muscle.
Yeah, I mean, like we can release stress, you know, by running or what?
Yeah, that is basically mostly control your skeletal muscle. Let's say you move around, all these things, but still you have to consciously control. Sorry, you have to consciously control. That means you can think about it emotionally. You can emotionally do not want to feel the stress. As I said just now, some of the minor things just take. Okay, don't take things too hard, and you find it difficult to actually get through it. Remember the response to stressful situation, these slides that I show you? Yes, Jana.
I was going to ask you about the mechanism action of cortisol.
Yeah.
When it binds to its receptors, does it basically promote the production of the enzymes which may be called lipolysis?
So it basically produces enzyme for gluconeogenesis and lipolysis. It depends on which organs or cells that is attached to. And we say that all cells have cortisol receptors, so basically it's present everywhere. Okay. Remember this, the response to stressful situation. So the first 3 minutes after threatening situation over the real image, these are basically once the body start to relax, and then your heart rate will start to reduce. Okay, this is the first 3 minutes after a threatening. In the second stage, and this activity basically activates the nervous system, and then the adrenaline is secreted. Your cortisol level will start to increase above normal level. So corticosteroid secretion will start to continue. Okay, but if the stress keep on going and the body is unable to cope with it, basically all this cortisol level is going to increase even further, and you basically go into hyper stress. Then this is going to be a chronic stress. So we must be able to know consciously how to basically reduce all these levels so that you don't really face much of a going into hyper stress situation. Is that okay? Okay. The last one we talk about stress management. This one already done. So I already give you the tips on how to manage stress. This one is already done. So we go to set D here. This is possible the secretion of stress hormone that affect J and K. For instance, J taking exam, catecholamine secretion, yes. Glucocorticoid, yes. Mineralocorticoid, no. Physiologic effect is basically increased alertness and heart rate. Okay, your blood pressure increases. Yeah. Same thing for K. They are basically the same when they are taking exam. But sometimes for K, probably is even worse because he knows that when he take an exam and then he feel that he's not doing well, then he start to get further stress, then it become chronic stress. So his glucocorticoid is going to be even higher and you become chronic stress. Okay, so that make him even worse compared to J. J, after taking the exam, he knows that he is doing very well of the exam, so he will be happy with it and he probably can enjoy his days going for a jogging. Okay, so you can put many other instances there. Yeah, let's say even more stressful, so it becomes even more chronic stress. So this can actually get on and K will become worse and worse because the chronic stress keep on developing. Yeah. So I leave it to you to fill answer. Then question 24, we talk about demonstrate relationship with the target cell, the hormones, target cell receptor, signal transduction. Epinephrine, let's say target cell SA receptor, G alpha S, signal transduction, ACTA, adenine cyclase, all this. You can do it on your own, yeah? Let's say cortisol, hepatitis, increase of enzymes for gluconeogenesis. So this one you can actually feel yourself. So I leave it to you to do it. And then number 10, you can justify the marks that you can give compared to J, K, and yourself. And trying the effect or stress, you can figure that out. So I leave. If okay, then we are done.
Yeah, Doctor, I just have one question.
Yes.
Okay, so earlier my group was trying to think about pathological conditions which can cause stress, and so we thought of Addison's crisis. So Addison's crisis, you have low cortisol, right? So can you just give me a relation on how this person faces stress, like how stress manifests in an Addisonian patient?
Addison disease. Because in Addison, there is a crisis. You don't really, for people who are stressed, they don't actually go into Addison crisis because it cannot be their cortisol level is low.
No, what I'm saying is like, would this patient face stress during this disease? I mean, because you said that stress is basically anything that abrupts your normal mechanisms, right?
Okay. Let's say Addison, for patients who are having Addison disease, will he face? Right.
Yes, yes.
But we should not forget about the sympathetic activation that is still being activated by the sympathetic. So you have epinephrine still being activated. So he still have the stress response, which is probably due to the neurocyte. So you will have high blood pressure, vascular constriction. So all this can happen. Okay.
All right. Okay, Prof.
So we are done. I hope we have covered and managed to meet all the learning outcome or learning objective. If we meet the first one, I think we do quite a lot of the autonomic nervous system. Compare and contrast between acute and chronic stress, I think that is also done. Right. And especially using J and K as an example. And then the factor effects indices of release of stress hormones. We talk about cortisol. But we miss out one is the epinephrine because it's not in your question. So corticoids. And also there's other parts like actually ADH is actually being released also. So it was not done here, so we can move on. And then the relationship between nervous and endocrine system regard to stress. So I think I have covered everything. Okay, any other questions? We have exceeded almost 15 minutes now of your time.
Doctor,
Yes.
regarding the conscious control of stress, right?
Yes.
Does it have anything to do with the hippocampus and then how it affects the amygdala, which then affects the hypothalamus and then affects the autonomic nervous system?
It do, because your hippocampus is the one that is modulating your autonomic nervous system. Yeah, it's the one. So your hippocampus is the one that is modulating your autonomic nervous system, which will help to basically modulate your autonomic who are meditating or some very calming situation, you can actually reduce the heart rate. Okay.
Thank you, Doctor.
Thank you. Any other questions?
Doctor?
Yes.
I just want to confirm that for J, his mineralocorticoid is not really affected, but for K, his mineralocorticoid is affected, right? Because he undergoes a prolonged stress.
Yes.
Okay, thank you, Doctor.
Yeah. Come. Any other questions? No? So this will be the last class. So I wish you all the best. You have tomorrow for your preparation, and then on Friday you have your online assessment. I wish you the best for your coming end of course exam. I hope everyone will be able to do well. Thank you. Thank you.
Thank you, Doctor.
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 Thank you.